Welcome back, everyone. We are starting and finishing chapter 2 in this video. And what we're going to do is we're going to come up with a frequency distribution table. And I want to illustrate that. So here we have wait times for a fast food restaurant during a lunch. And you can see the data that we have there. It's just a bunch of numbers. It has no real meaning for us. And so until we can organize it in a way that we can actually make sense of what we have here, there's no reason of using the raw data. So what we've done is we've organized it into this frequency distribution table right below the data. And this is actually useful because we can see that there were 11 people that waited between 75 and 124 seconds. There were 24 people that waited between 125 and 174 seconds, and so on. And we can actually make use of the data now that we have this. This is certainly not the only way to organize data, but this is one way that can be very useful for us. So let's get into it. We're going to talk about frequency distribution. Shows us how data are partitioned among several categories, and you'll hear me call them classes. I don't usually call them categories, I call them classes, by listing the categories along with the number or frequency of data values in each of them. And we have some definitions. Make this a little bit smaller so we can see that table as we're doing this. We're going to start with the lower class limits. Are the smallest numbers that can belong to the different classes. And so let me go ahead and list those. So for our table, that would be the 75, 125, 175. So it's the bottom of each of these classes. And as you can imagine, the upper class limits are the data that are at the top of each class. That's the 124, 174, 224, 274, and 324. So not too bad. Next up, we have the class boundaries. These ones are a little bit weird. These are the numbers used to separate the classes, but we're closing the gaps. So for example, if we look at our table up here, let's say that my wait time was 124.7 seconds. That means I'm not represented on this table because there's nothing between 124 seconds and 125 seconds. So what we're going to do is we're going to drop everything down by 0.5, the lower class limit, so 74.5, and we're going to go up 0.5, the upper 124.5. Now when I go down 0.5 for the 125, you'll notice it's the same as over here. The 124.5, it's the same. And now there is no gap, which is the point. 174.5 and so on. So our class boundaries are going to be 74.5, 124.5. And notice I'm just going to list it once. I'm not going to list it twice. 174.5, 224.5, 274.5, and 324.5. Those are our class boundaries. This won't be useful to us until we get to the graphs of these, which are called histograms. We will get to that in this video eventually. We have the class midpoints is next. And these are usually used to represent an entire class for us if we just find the midpoint. So let me go up here. To find the class midpoint, I'm going to go the lower plus the upper divided by 2. 75 plus the 124 divided by 2. So 99.5. Next up, we have the 125 plus 174 divided by 2. 125 plus 174 divided by 2 is the 149.5. And you can see we're just adding 50 to these each time. So as we're listing these, plus 50, plus 50. Yep. 199.5 to 49.5 into 99.5 are our class midpoints. Now, again, we will use those here in a few minutes. Our last one, as far as definitions go, is the class width. And this is the difference between two consecutive lower class limits. And so I'm going to take the 275 as the lower class limit of the last class. We can barely see at the top there, minus the 225. Oh, try that again. 275 minus 225. And that gives us a class width of 50. Now, this is how we find the class width if we already have a table. If we're trying to make a table, then we have to come up with a different way of finding the class width, which we will do in just a moment. Let us move on. All right, Mr. Chen gave his students a biology test last week. Here are the test scores for each of the 12 students. Complete the grouped frequency distribution for the data. In the distribution, the frequency of a class, right, okay. You'll notice that the class width is 5, meaning 84 minus 79 gives me 5. So I want to point out that we are, to get to the next one, we're adding 5. And that's what the class width is. All right, I have already put this data into my list. I have it under list 1. You can see the 92 and the 90 and so on. You may need to pause this video to put that data into your list, but I'm going to continue on. I'm going to sort my list, and I'm going to sort it from the smallest number down to the biggest number, and that's called ascending order. I'm going to click on Stat, and I'm going to notice number 2 here is sort A. That's sort in ascending order. And now it wants to know which list I want to sort. Well, my data is in list 1. And if you look at the number 1 on my calculator here, just barely above it in blue, it says L1 above it. So I'm going to hit the blue button second, and then hit the 1, and it'll say L1. So I wanted to sort list 1 in ascending order. I hit enter. And I'm going to go look at my data, stat, edit. And I'm just looking at list 1 for right now. So I want to know how many values are between 79 and 83. And I'm looking at my list 1, and I see the 79, that's 1, 3 80s, that's 4. Yes, that's 4. So what's the frequency? There are 4 from 79 to 83. How about from 84 to 88? I just see 1. I just see the 85. So 1. 89 to 93, 1, 2, 3, 4, 5, I'm seeing. 5. And 84 to 98, 94 to 98, pardon me. 94 to 98, I'm seeing just 2. That's the 95 and 97. So that's how you fill in a frequency distribution table. And now we are going to make our own frequency distribution table. The heights in inches of commonly grown herbs are listed below. Organize the data into a frequency distribution table with 6 classes. Now, when we found the class width before, all we did was look at the table that was already created. Now we're trying to create a table, so we don't have that. They tell us they want 6 classes, and here is the formula in which we are going to use to come up with our class width, which we need. We're going to take the largest data value. Now, I want to point out this data I have put into my list 2, 18, 20, 18, 18, and so on. So I'm just going to focus on my list 2. You may need to pause the video to put this data into your calculator so that you can practice this. But, oh, what I just hit, let me do that again. To get out of this, what I'm going to hit is second, and then right next to it, the button just to the right, it says quit right above the mode button. And that's what I'm doing. I'm quitting out of that so that I can get to my regular command line here. All right. I'm going to sort my data. So I'm going to hit stat, sort ascending order, and my data is now in list 2. So if I hit second and I look at the number 2, it has the L2 above it. There's my L2. And it sorts it for me. I'm going to go back into the data, stat, edit, and I'm looking at list 2. And to find the class width, I'm going to take the largest data value. I'm going to go to the bottom of list 2 here. That is 36. Minus the smallest data value, which is 7. I'm going to divide it by the number of classes, which I have right here. And that is going to give me my class width. So, oh, let me do that. So I'm going to quit out of that second quit right next to it in the mode. 36 minus 7 equals divided by 6. So I'm getting 4.83 bar. And if we look at this, we are always going to round up. We want to make sure we capture all of our data. So this is going to go up to a class width of 5. Now we have everything that we need to make our frequency distribution table. So here we go. We're going to have the height and the frequency. I'm going to start with the lowest number. Stat edit. The smallest data value I have is 7. So that's where I'm going to start. And I'm going to use my class width, which is 5, to get the next class. So I'm going to add 5 to 7, which is the 12, plus 5, 17, plus 5, 22, plus 5, 27, plus 5 is the 32. Here are my lower class boundaries, lower class limits. And the way I got that was I just added 5 each time. Plus 5, plus 5, plus 5, plus 5. Now we need the upper class limit. Well, I'm going to look at the second class limit, and it starts with a 12, which means the number just before 12 is 11. I'm going to look at the third class that starts with 17, which means the previous one's going to end at 16. And notice I'm just adding 5 each time. So 11 plus 5 is 16. 16 plus 5 is 21. 21 plus 5 is 26. 26 plus 5 is 31. 31 plus 5 is 36. And there are my classes. So I'm looking at list 2. And I'm going to notice between 7 and 11, I see the 7 and the 10. There are 2 in that class. And from 12 to 16, I'm seeing 1, 2, 3, 4, 5 is what I'm seeing. (17 to 21), I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. And from 22 to 26, I see 2, the 2 24s. From 27 to 31, there are none. And from 32 to 36, there is 1. And here is our first frequency distribution table. Yay. All right. Let's move on. We have some variations that we can deal with. The first one is called the relative frequency distribution. And sometimes we call this a percent. And so instead of using the frequency, we're going to use a relative percent. And we're going to do that by taking our table. Here's our table of wait times again in seconds. And we're going to change this from a frequency distribution to a relative frequency distribution. So this is going to be a relative frequency. And one of the things I need to do first is I need to add up all of the frequencies. I need to know how much data I'm dealing with total. And it looks like we're dealing with a total of 50. And why does that matter? Well, we'll see right now. Our relative frequency is, I'm going to take the number in that particular class, the 11, and I'm going to divide it by the 50. That gives me 0.22, or we could write it as a percent as 22%. Next up, we have 24 divided by 50. Next up, we have 10 divided by 50. Three divided by 50. And then 2 divided by 50. And in theory, if we were to add up all these percentages, we should end up with 100% of the data. Now, occasionally, that won't add up to 100. If we had to do some rounding off, we could end up with some slight round-off error where if we added them all up, we would get like 99.8 or 100.2% or something like that. But in general, it should be around 100%, hopefully not too much round-off error. All right, that is a relative frequency distribution table. Now let's move on to another one called a cumulative distribution. In which the frequency for each class is the sum of the frequency for that class and all the previous classes. And for this one, we're going to have to sort of rewrite it. Time, and this is going to be and the way we're going to write this is I'm going to look at the second class here. It starts with 125. And so my first one here is going to be less than 125. And there's only 11 that are less than 125. Next, I'm going to do less than 175. That is going to be the 11 plus the 24. Now you'll note you don't have to write 11 plus 24. I'm doing that for teaching purposes so you can see where I'm getting my values from. Less than 225 is going to be the 11 plus 24 plus 10 less than 275. These ones we can do in our heads. So 11 plus 24 plus 10 plus 3 is 48, and less than 325. We should always end with what we know the total is, which is 50. All right. And again, the only thing you need to actually put if you were filling one of these in would be these numbers here. You don't need to actually write all that out. Again, I'm just showing you where I'm getting my values from. And we are going to introduce the idea of a normal distribution here. And a normal distribution is going to generally have a shape like this. It's what we call a normal or a bell-shaped curve. And the idea is that all of the, oh, that is the wrong one. All of the middle data is where most of the data is. And then it tapers off at the extreme left side and the small side. And you can see that in the actual graph here. All right, so let's move on to part 2, which are the graphs of these things called a histogram. Is a graph consisting of bars of equal width drawn adjacent to each other. The horizontal scale represents the classes of quantitative data values, and the vertical represents the frequencies. We can also do a relative frequency histogram. It's the same shape and horizontal scale as the histogram, but the vertical scale represents relative frequencies as percentages or as probabilities. And here we have a problem from ALEKS. A purchasing manager at a university is investigating which brand of LCD projector to purchase for equipping classrooms. Of major concern to her is the lifetime of the light bulbs used in projectors. One company has published the following histogram regarding the lifetimes of the sample of 50 bulbs used in LCD projectors. Now, I will say for the example that I have here, they have the percents already out there for you. Some of them in ALEKS will have numbers there. You'll need to add all the numbers up. That'll be your denominator. And your numerator will be whatever is the less than or the greater than as you're looking at this. Based on the histogram, find the proportion of bulb lifetimes in the sample that are less than 800 hours. I've drawn a boundary of 800 hours there. So this basically is saying we want to add up the 0.1 plus the 0.12. So about 22% of the bulbs last less than 800 hours. And here's some more graphs. The left red one that you see here is a regular frequency distribution, and the right one is a relative frequency. So you can see on the left one, it has the frequencies, and on the right one, it has the percents on the vertical axis. Below are some common distribution shapes. Here we have our nice, pretty normal looking distribution. We like to see that. We can do a lot with that as far as projecting and things like that, coming up with probabilities. The one just to the right of it is called the uniform distribution. These ones are super boring. This means that everything's equally likely to happen. But again, not too interesting. The part that we want to focus on are these next two. And a distribution is skewed if it's not symmetric and extends to one side more than another. And I want to point out that this one here has a longer right tail. This one here has a longer left tail. And so we say data skewed right have a longer right tail. And data skewed left have a longer left tail. All right. Shapes of discrete distributions. So we have 3 histograms here, A, B, and C. And we're going to learn a new word here. When we have 2 bumps in the same graph, we call that bimodal. So which is best described as bimodal? That's definitely histogram C. Which is the closest to being symmetric, and we can kind of see This one's doing its best to be as symmetric as it can. I'm going to say it's histogram B. And which is closest to being bell-shaped? That's also histogram B. And which one is skewed left? Remember, skewed left means that we have a longer left tail, and we can definitely see that here. So that's going to be histogram A. All right, let's do some practice. Below are some times and days it takes for a sample of 15 customers from Jack's computer store to pay their invoices. Now, this one says the initial class boundary is 14.5. The class width of 9. So I'm going to go 14.5 plus 9 to get the next one. 23.5 plus 9 to get the next one. 32.5 plus 9. 41.5 plus 9. 50.5. Now, if this isn't enough, if we need another class, then we push this button, and that'll add another one. Now, I would need to manually draw one in if I'm doing notes like this, but on ALEKS, you can just click that button and it'll add another one. For our example that we're doing here, we have the right amount, but and also you would use this one if you needed to subtract one, if they had too many displayed. All right, the data that you see here, I have put into my list 3. You can see 19, 15, 43, and so on. So I'm going to start out by sorting my list 3. You may need to pause the video to put the data into your calculator. So I'm going to stat sort ascending order, list 3, second 3. I'm going to go back to my data. I'm looking at list 3 only. How many are between 15 and 23? 1, 2, 3, 4 is what I'm seeing. So hopefully you can draw much nicer than I can. The 4 at the top. In ALEKS, you just take the little finger there and you click down and just drag it up to 4. Between 23.5 and 32.5, I see 1, 2, 3, 4, 5. And between 33 and 41, 1, 2, 3, 4, I'm seeing 5. 5. And between 42 and 50, I'm seeing 1. There it is. All right, let's talk about some other types of graphs other than histograms. Here we have a bar graph. A local real estate company has 4 real estate agents. The number of houses that each agent sold last year is shown in the bar graph below. So we have Bob, Liz, Maria, and Kenji. And let's answer some questions. Which agent sold the fewest houses? I'm going to do this just to help me. It looks like Bob sold 2 houses, Liz sold 4, Maria sold 11, it looks like, and Kenji sold 4. Which agent sold the fewest houses? Easily Bob, because he only sold 2 houses. How many more houses did Maria sell than Kenji? Maria and Kenji. Maria sold 11, Kenji sold 4, so 11 minus 4 is 7, so 7 is my answer there. And how many of the agents from the company sold at least 2 houses? That's all of them. So that's all 4 of them sold at least 2 houses. Bob barely made it. All right, a line plot is what I've always called a dot plot, but we'll call it a line plot because that's what ALEKS calls it. All right, it's very simple. I just go here to 4, put a dot, 7, put a dot, 5, put a dot, 4, put another dot. 7, put another dot. 9, put a dot. 7, 4, 5, 4, 5. That's it. Now we can see that this is not very normally distributed. We don't get that nice bell shape to it, unfortunately. That's okay. Next up, we have stem plots, or a stem and leaf plot. The way that we read this data here, this is 18 students in Professor Chen's advertising class. And we're going to answer some questions. Now, the way we read this is 2 students got a test score in the 60s. So one of them got a score of a 63, the other one got a score of a 67. In the 70s, there are 5 students that got a score in the 70s. One of them was a score of 72, a score of 73, a score of 76, a score of 77, and a score of 78, and so on. I'm not going to read them all to you, but hopefully that's making a little bit more sense. What was the lowest score in the 70s? So I'm looking at the 70 list, and the lowest score there is a 72. What was the highest score overall? Well, I'm going to go to the 90s and all the way to 97, it looks like to me. And how many students scored in the 80s? Let's see, 1, 2, 3, 4, 5, 6. I'm seeing 7 that scored in the 80s. This is a particularly nice way to see your test scores, because then you can see how the whole class did, and you can see where you fit in. You're looking, you find your score, and you're, oh, I was in the middle, I got an 85, or I did really well, I got a 95, or I did terribly, and I got the 63. Gives you a good idea for where you are without anybody else knowing what you got. And we are to our last problem. We are going to create a frequency distribution table based on this data. In a survey, 25 voters were asked their ages. The results are shown below. Construct a frequency polygon to represent the data with 5 classes with a lower limit of 20 and a class width of 10. They've made this very easy for us, so that's very nice. So we're going to start here. Age and frequency. It wants to start with a lower class limit of 20 and class width of 10. So this is 30. So it's nice when they do that. They kind of give that to us. I'm going to put this data, I believe my data is already in list 4. You can see there 43, 56, and so on. You may need to take a minute and put the data into your calculator. So what I'm going to do is go ahead and sort my list 4, stat, sort A, second 4, where L4 is. I'm going to take a look at my data. So I'm only looking at list 4. And let's fill in our frequency distribution between 20 and 29. So in the 20s, I see 2 of them. In the 30s, I see 1, 2, 3 of them. In the 40s, I see quite a few. I see 1, 2, 3, 4, 5, 6 of them. In the 50s, I see 1, 2, 3, 4, 5, 6 of them also. And in the 60s, I see a lot. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to quit out of this, second quit. I'm going to go ahead and add those up. 2 plus 3 plus 6 plus 6 plus 8. And that is 25, which they said is what I need. Now, to do a frequency polygon, I need to find the midpoint of each of these. And if you remember, to find the midpoint of each class, I'm going to do 20 plus 29 divided by 2. So this is 24.5. 30 plus 39 divided by 2. And notice that I'm adding 10 to each of those. This will be 44.5, 54.5, and 64.5. And what I'm going to do is I'm going to go to a class that is below the age of 20 and find its midpoint. That's going to be the 14.5. And I'm going to go to a class after my last class, so 70 to 79, which isn't there. And that's midpoint is going to be 74.5. And I'm going to label my horizontal axis based on these numbers here. And my vertical axis is going to be my frequencies. And because the largest frequency I have is 8, and I only have 4 ticks here, I'm going to go by 2s. So 2, 4, 6, and 8. And I'm going to, of course, start here, which is at 0, because there's nothing in the class of 14.5. And we are going to end also at 0. And I'm going to label these where the frequencies go. So the class that's represented by 24.5 has a frequency of 2. 34.5 is going to be 3. 44.5, I'm up here at 6. 54.5, I'm also up here at 6. And 64.5, I'm up here at 8. And I am going to connect these with straight lines. Well, the best I can draw straight lines, I should say. And there is our frequency polygon. I hope that you found this helpful.